Today with all of you guys spending here the time here with me to Kochi. So amazing. Like we have two years here quite here. So I'm very glad I can be here. So thanks for that. Yeah, today what I will be talking about is AIOps with open source. So let's get started. Let me just so I am heading directly to the topic. Why? Because like I think the introduction given to me was pretty top. I can do that in better. So let's get started with the directly with the topic itself. So as an overview, like what I will be talking today. So life of a site reliability engineer, what it will be, I won't be trying to cover all the functionalities or duties of a site reliability engineer, but I will try to cover most of it. As I am working as a site reliability engineer, I can cover that. Then traditional monitoring and its problems. So I am trying to build a ways to the top, like what I want to actually convey to you. I am trying to build a base for that. So that's how I have outlined the session here. Then I will be talking about AIOps, what and how. So AIOps is pretty big topic. So I won't be able to cover all the aspects of AIOps here, but I will try to do better. Then I will be giving an example, like I will be giving a demo of AIOps with context focus, and then there will be a Q&A for. So let's start with the life of a site reliability engineer. So do we have any site reliability engineers here? Could you please raise your hand if you are working as a site reliability engineer or DevOps domain or a Linux engineer? This is okay. I can see two hands. Good. I know the majority of the audience here are students, but yeah. So are there any aspirants like who want to be a site reliability engineer or a DevOps engineer? Could you please raise your hands? Okay. Very few. Cool. So, life of a site reliability engineer, do you know how that is? Like what we do in our daily run? So, I will just skip to the next slide, you will see. So, yeah, this is how our daily run looks like, you know. So, it will be always firefighting situation, like there will be something happening in the production environment and we need to go troubleshoot and fix the issue. So it's mostly like that, like whatever happens on production is our responsibility. So we need to keep the application up and running always. The user should be able to access the service on that web platform or mobile application. Whatever happens from that, if the user is not able to access the application, if the SLAs are out of control, then we need to jump in. Whatever time it will be, we need to jump in and we need to find out the root cause, what has happened in the past time, why it is failing now, and we need to do all those investigation and find out a fix for that and make it against you. So that is what we do in our daily life. So yeah, so as I mentioned, it's mostly firefighting what we do, right? So what might be causing this issue? You know, like this are some of the issues which I have jotted down. So there can be bugs in new feature releases. So I am currently working with a startup. So their release cycles is very high velocity, like they do releases every hour. So whenever they start working, they do releases every hour. That is kind of headache for me as a site reliability expert. Because every feature might not be tested well. So there will be a rush from the investors or the CEOs that this features needs to be gone out today. So that is the deadline which is given to the developers. So they will work towards that. They are also very agile. They are also very agile and they develop and deliver features. But those features might not be tested well, right? So in such scenarios, there can be bugs arising in the application. There can be a memory leak. So most probably you might have heard this. It was working well in my laptop, or it was working well in the dev environment, but it got blocked in the production. So why is that? Why? It is because in your laptop or in your dev environment, the scale is very small. The number of users or the number of traffic, the traffic volume coming to the application is very small in development environment or in your laptop. But in production, it is massive. It is enormous. Like we cannot predict what is going to happen in a production environment. So in such a big enormous traffic coming in, the application can drop because of something gone wrong in the code. If it is not well tested, then it's gonna be a headache for a security engineer. So then there can be hardware issues. So you might be thinking many of the people are now using AWS or Google Cloud, or there will be a cloud. So that's why do we need to care about these hardware issues? It can happen, like even in AWS or Google Cloud, a server can go down, like there can be hardware issue or something wrong in the memory or hard disk. It can happen. So even if that goes down, the remediation fixes which we need to do manually, maybe we need to go and stop the server and start the server again. So such remediation we need to do. Then it can be DDoS attack or increased traffic. So DDoS attack you might be familiar of, right? So there will be some people who would want your business impacted, your service. They need to shut down your service and get your business impacted. Mostly this kind of fighting happens in startup ecosystems. So I have seen, I'm dealing with that in my day-to-day life. So then other thing is the bottlenecks of third-party APIs. So a product which we are building, so initially we might not have all the features created and built in-house, right? For some of the features we might need to use a third-party API for some of the features, and there will be certain rate limit. So when there is a big traffic coming in, that rate limit is going to exhaust, and there will be such problems. So if you have not planned well for or scaled well, then there can be issues in production. These are just very few issues which I am facing in my day-to-day run as a site reliability engineer or a DevOps consultant. I just got it down here, but there can be many. So now you might be questions like how we are tackling this kind of issues, right? So we do tackle these issues happening in production with proper monitoring and alerting. So this all are like we might be, our application might be running like thousands of servers, right? So or it might be a serverless application. It can be an application running in Kubernetes platform, a containerized application. So monitoring, if this is all running without monitoring, how will you know like what if something goes wrong? If something is going off, how will you know? Like the environment is very big. There are many servers. There are many components in your application, right? So if something is going off, how will you know? If there is no monitoring and proper alerting setup, how will you know is like whenever something is going off, like if your application have gone down, some user will complain, or it will be coming up in Twitter that hey, this application is down. Is there an issue? Or is it only for me, right? So that's how we will get to know. Our users will start complaining that the application is not working very well. But we tackle all these issues reactively with a traditional monitoring setup. We monitor critical system metrics for all the servers or all the applications which we are maintaining or managing. So we will do monitor that, proper monitoring setup, and we will have alerts configured for certain metrics which we need to monitor, right? So those rules we have to define at the very beginning, when before even we go to production. We need to understand which are the service level indicators which we need to monitor. So after analyzing, like having a list of that, we create monitoring dashboards for that, and then we create role-based alerts for that. For example, for very basic example, if memory usage is going above 70%, I need to get an alert. Or if my application, there's a health check endpoint, let's say there's a health check endpoint slash health in my application, and if that is written 500 or any other status code rather than 200, that means my site is down. So if that is happening, I need to get an alert. So this kind of rules we can write. That is the first step. Before we go into production, we will write all these rules and we will create all these content dashboards, and then only we will plan to go to production. That's how we can tackle issues happening in production. So this is our traditional setup. Then now, whenever there is some alerts happening, alerts going to get triggered, that the application is done. What we do? We go and fix it. Like we try to find out what caused this problem, and we then fix it. So that's the time needed for that. Like we get an alert that will be based on a symptom, right? And it won't be based on a cause. So we need to find out the cause for it. That we cannot even predict what could be the cause, and how much time it will be needed to understand that cause, to find the root cause basically, and then we need to fix it, right? So these are some ways how we tackle production issues for all the application platforms we will manage. So reactive-based proactive approach. So as I mentioned in the last slide, let me just go back quickly there. So all these are kind of reactive, like when a particular threshold is reached, like the alerts we configured in similar fashion, like if the value of memory usage is more than this, give me an alert. Or if CPU utilization for this particular service are more than this, give me an alert. So this kind of alerts are configured based on a threshold. So that is basically a reactive approach, right? So whenever we hit the limit, we get an alert and we just go and fix it, right? So but what proactive means is, it is also similar, but these alerts are set on forecasted data. Like there can be metrics which we can forecast, right? So all this metric data is on time series database. So for a given time Y, there will be a data X, right? The CPU usage for a particular time will be dispatched. That we know. So as memory usage for a system at the past 10 minutes, we know that's in a time series XY graph. So that is more reactive. And what is proactive is, based on this time series data, we try to forecast these metrics using open source AI tools, right? And then we set alerts on that forecasted metrics. Did you understand what I am talking about? Do you have any questions on reactive and proactive approach? That is something which I want you guys focus on, because that is the problem what we want to solve. Okay? Okay, so here is a sample graph. So I'm not sure whether these values are readable for you guys, but it is just XY graph, right? So you can see I have the data points over here and the time over here, right? So here if you look at, so this is the actual, the green point is the actual data point, and the yellow is the forecasted data point, and the blue area is the trend. So if you are familiar with, how many of you are familiar with the AI issue getting concepts? Okay, so you guys may be probably familiar with the forecasting and such use cases, right? So here, When we predict a value, we call that y hat. Okay? And when we predict a value, that's not something, we also get a y hat upper and a y hat lower. So for a given time, this can be the maximum value, right? This can be the maximum value for a given time for that particular metric, and this can be the lowest value for that particular metric. So what I have plotted here is the above blue line is the y hat upper, and below blue line is the y hat lower, and the grey line is the y hat, the yellow is the y hat which we have predicted, and green is the actual data. Okay? So this I just want to show as an example of how a monitoring dashboard looks like. Maybe give me a second, let me open another. Okay, I will show that I have a monitoring dashboard created already. So I will show that during the demo. Like I will take 5 to 10 minutes for the demo. So I will be showing you some of the dashboards which I have created for monitoring some of the system metrics, and I will explain furthermore over there. So let's get to the next slide. So the AOs which I want to talk about is the way how AOs can help site reliability engineers help to deal with issues even before they happen. Right? So even before they happen, how they can deal with these issues with AOs. That's what I want to talk today. So AOs, like if you think about it, like if you separate these two words, A and Ops, there are many things can happen. Like operations means it can also be customer support. So if you are automating something that automating some of that stuff with chatbot or something, that's also AOps. But that's not something which I want to talk today. And many people have a misconception that AOps means alert correlation, right? That is not just alert correlation. It has several aspects for it. Like AOps means many other things too. And today what I want to talk about is how this forecasting use case can be applied to our SRE related problems, and how we can probably solve certain problems, right? So here I want to introduce an open source tool called X4Cast. So I have been working on this project for last few months, maybe like 4 months for now. So we have this tool is completely open source. We are also working on a closed source for this particular project, but majority of the features we have available that open source. And the best thing I want to share here is that this tool is developed completely by students like you. So this is a tool something which is created by freshers. Like they were just waiting for to join the company. Like there was a like once they were hired for to join a company, and they were just sitting idle, but they don't want to waste their time. They want to do something productive. So they reached out to me. I put this idea to them, and they were interested. So we collaborated and built this product. And this project is open source, and anybody can use it. I haven't talked much about this project because this was not in a mature stage, but now it is. That's why I'm here and talking about it. So certain features of X4Cast. So here, we support Prometheus and InfluxDB as data store. So have you guys heard about Prometheus, InfluxDB tools? No? So Prometheus, InfluxDB, they are time series databases. Okay? So you can store any value in a time series structure. You can probably use these tools. And these tools are pretty standard for our monitoring or observability infrastructure. So everybody uses Prometheus stack Prometheus Grafana stack for Kubernetes module. So now that is something pretty top standard here in our landscape. So we now support Prometheus and InfluxDB. And then the core feature, data forecasting. So we do data forecast, that is what Xforecast does. Like it does data forecasting on time series database. Then we have some features like hyperparameter included. There are certain limitations for that, but we can do that at certain level. We can do some tuning for that particular model. And then we have multiple metric forecasting. Yeah, it's not like we can only forecast a single metric. Like if you want to forecast on memory and also for the hard disk usage or for the CPU usage, all of that you can do. Or even how many people are coming to your website. If you are collecting that metrics, change rate, you can also forecast such metrics as well. Then it is container native. It can run on any platform where there is a container runtime. That doesn't mean that it can only run on any platform where which is where there is a container runtime. It can also be run on a VM. So in the demo I will be running that on a VM. So the use cases, there are not much. I just pointed out like 3 use cases. So you can do seasonal forecasting, then linear forecasting and anomaly detection. So if you can recollect the graph which I showed you, like there is a upper and lower value, right? So if even any value like at a given point of time in the future or the current time, if the value is going above the upper value or below value, or if it is going below the upper value, that is an anomaly. So anomaly detections can be done with the Xforecast pretty easily. And seasonal forecast, like if there is a seasonality in your data pattern, like if the thing what you are plotting is kind of how many people are coming to your platform, right? The traffic of your platform. Maybe for some reason, most of us users Instagram or any social media application during the evening, right? So at that time, the traffic will be at the peak in your application, and on your day hours it will be very less. So there is a seasonality for that kind of metric, right? So for such use cases, to understand when more users are going to come into your application, to deal with such use cases, we have seasonal forecasting also in our Xforecast application. Then linear forecasting, based on past data points, we can predict the future data point. So here is a high-level architecture diagram. So we have forecaster here. So the Xforecast, this project is completely written on Python. So how many of you know coding in Python here? All of you should be knowing Python, right? There are not many hands here. Could you please raise your hands again? So Python should be a must-known language to all of you, because that is kind of a system knowledge which you can have with you always. This one language can be used in many domains, right? We can use that for developing the data application package, right? And the same code we can use for your data set project, and the same language you can use for writing scripts as a DevOps or SRE engineer. I have been using I have been writing code in Python for the last 7 years. So our forecaster application is a Python-based application, and we have like how it is connected to is like we have data store, Grafana, alert. So this part is a traditional observability stack. So there will be Grafana or any visualization tool that we use in an environment. So what it will do is, I will show you what Grafana tool is. So we will have monitoring dashboards created in Grafana. So Grafana basically correlate with the data store and get fetch the data and visualize all the critical metrics beautifully for you. And then we can also configure alerts for those critical metrics using Grafana X. So we can just plug in. That is the beauty of Xforecast. We can just plug in export us to your current observability infrastructure. There is no additional cost. You can just plug it as a new plugin. It can run on a VM or a container, or even if you come to observability stuff, it can run as a pod or something like that. And it just need connectivity to the data store. That's all. That's all what it means. So let's just jump into the demo now. So this is the Grafana tool which I have mentioned earlier. So this is a pretty standard tool which we use in our day-to-day run. And I don't think any other tool can replace this. So any enterprise tool is having their having their observability infrastructure on open source might be using Grafana. I'm 100% sure about that. So here you can see CPU related metrics and other metrics as well. So here we have CPU, memory, network, this, and many metrics we can see here. These are all our time series database. Like what this dashboard give you is that how much this resource was used at a particular point of time, right? So if there is a spike like this, so it can happen for IO utilization. So IO utilization can be spiked sometime. This is a normal trend. It's a baseline of a particular graph. So if it is going above a particular value or below a particular value, then we need to get an alert. That alert configurations also we can do that here. Alerting alert tools, we can do that here. So now let me go back to general. So this is something which I want to show you. So here is actually Exporters is running for the past few days in this environment, and it is being predicting some values for like 2-3 days for now. So here if you see, look at the first graph. So it is predicting this price data. Okay, here is the prediction. So if you see here, the green one is the actual risk price data, and the yellow one is the predicted data, and blue lines are y hat upper and y hat lower. So ideally, if your model is right, your value should be coming between this value, like should be coming between your actual value and the predicted value should be coming between the y hat upper and y hat lower. Right? But here there is a lack of data, I believe. Like we only started the data collection and training for this like 2 days before. So it doesn't know, the system doesn't know all this volatility of this particular metrics. But just for something to show you guys, we have created this. So this is a graph where we are just predicting by hand based on the past few data points. So for a particular, for example, like for the past 10 minutes, the data, actual data is like this. So we are passing that to the model, and then we are predicting for the next 2 minutes. That's what we are doing now. So here in the second graph, so here we have added, these are all not tuned well, but here we have added an additional regressor or a feature. So let's say a general or an easy example. So how you predict rain? Do you know like how people predict climate? Like for example rain, weather forecast. Like there can be a chance for rain, right? So that kind of forecasting, do you know how that is done? So it is not just done based on the past history, like at this point of time, for the past 30 years, there was rain, so there is a chance for rain. That's not how it is forecasted, right? So there are other metrics also, which is being considered to predict that there should be a bad climate today, like humidity. Humidity is a factor for predicting rain, right? So similarly, for this particular metric, there should be another factor which will be affecting this particular metric to behave like this. So if you know that, you can add that also. Like this is kind of multidimensional problem, multidimensional data problem, where we have data features of multidimensional, and we are forecasting how it is. We are predicting how that multidimensional data is going to affect the data point which we are trying to forecast. Okay? So this is adding a single register, additional feature. So there will be a one more vector to give this prediction. But you can see here it is not predicting so well. The green is the actual data and it's not being predicted so well. And here it is double regressors and here it is hyperparameter too. So these are all done manually, but it's not kind of perfect. So let me just take a like first 6 hours data. So now if you see, it's almost perfect. So if you are looking at a point of view, like when we have a lot of data, and if you are looking at this point of view, then this is kind of more or less perfect, right? So we are capturing all the spikes, and we are also predicting the dip very easily, more accurately, right? So this is how we are doing this forecasting. So one more thing what I want to show you is, so you might be thinking how or where this would be running, right? So this is currently running on a VM. Let me just get into there. So maybe I think the time is up, but maybe what I can share now is the documentation to the tool. So we have a website also. You can find all the details about this project over here. So we are also building a UI for the tool. And from here you can connect with the some of the community and everywhere. So yeah, that's all about the presentation and the demo. So do you have any questions? Because like it's a one more thing, it's an open source project. If you would like to participate in collaborating with us, like for this project, if you would like to contribute to this open source project, you can just reach out to me, or you can just create a pull request. Yeah.
Basically, you were talking about the incidents to be more specific that gets created while some job failures is there, right?
Could you please repeat the question?
So basically, we were talking about the incidents that we had in service now.
Yeah.
If any job failures is there.
Not only that, so there can be. It depends on the your use case,
Okay.
right? So for example, what I am doing in our day-to-day job is like I will be monitoring a particular web application. If there are more traffic is coming, when is the traffic coming, and if that is coming, then I have to do certain tasks. Maybe I have to increase the provision concurrency of the lambda. I have to scale the application, scale the number of servers. So certain things I have to do to maintain the well-being of the application. So for the service now use case also this can be used. Yeah.
Any other questions?
Okay, so maybe you guys can reach out to me at the Vishnu page handle. I'm pretty active in all social media channels, mostly LinkedIn. But this handle, you can reach out to me in Twitter, LinkedIn, Instagram, Facebook, everywhere. Yeah. That's all, guys. Thank you.
Hello everyone. Yeah, so how's that session? Okay, thank you so much Vishnu for that insightful and amazing session on AI ops with open source. Now I invite Kiran to present Vishnu with a memento as a symbol of our gratitude for your valuable contribution for today's event. Thank you again Satish. Kiran, over to you. Okay, how do you feel about playing a small game? You don't worry, you won't have to get up. You just have to sit in your seats and do it online. So we're gonna play a small game now. Get ready with your phones. Come on everyone, get ready with your phones.